Hello everybody, and welcome to exercise 2 on page 49 of the workbook. This is another example of using the chain rule to calculate derivatives. Okay, and in this problem they're asking us to find the partial derivative of z with respect to u and v, given that z is ln of xy and x and y are the following functions of u and v. Okay, so let's approach this the same way that we approached the last problem, starting with the dependence diagram. So we're trying to find the derivative of z, and so we could ask, what is z a function of? Well, we can see from this formula that it's a function of x and y, so that's our starting point. And then the question is, what about x and y themselves? What are they functions of? Well, x looks like it's a function of u and v. And the same is true of y. That's also a function of u and v. Okay, so there's a tree that kind of describes the dependencies among variables. Okay, let's clear away some of the clutter here and get started calculating these derivatives. So we'll start with partial z partial u. Okay, and again, the diagram that we have over here to the right is a nice natural way of coming up with the formula for the derivative. Okay, so in particular, we're asking how many paths in our diagram are there that go from z to u? Okay, well, we could start maybe by just noticing that there are two places where a u occurs. And so the first path is going to go z through x and then to u. So first step in that path is z to x, so that's going to be partial z partial x. And then the next step in the path is going to be x to u, that's partial x partial u. Okay, that takes care of this path. And then the other path to u looks like this. Okay, we first go from z to y, then we go from y to u. So that's going to be partial z partial y times partial y partial u. Okay, and if we can calculate all those derivatives, we will have a formula for partial z partial u. All right, so let's start with partial z partial x. So we need to take our function, take its derivative with respect to x. So we're going to take the derivative natural log of something, so we're going to get 1 over that something, times the derivative with respect to x of the inside part. Let's see, the derivative of xy, we're going to get 1 for the derivative of x, and the y is going to come along for the ride. Okay, so all of that's the derivative of z with respect to x. Then we come to partial x partial u. Okay, here's our formula for x. So if we take that derivative with respect to u, we're going to be using the chain and the power rule, so we'll get 2u squared plus v squared to the first, and then we need to multiply by the derivative of u squared plus v squared. With respect to u, that's going to be 2u. Okay, and then move on to the next term here. Clear some clutter away and kind of do it all again. So first derivative that we need is the derivative of z with respect to y. That similarly is just going to be 1 over xy this time times x. Okay, and the derivative with respect to derivative of y with respect to u, okay, is going to be 2u cubed plus v cubed to the first times 3u squared. Okay, and we can do a little simplifying with that. Notice that there's a y there that cancels and an x there that cancels. Okay, and so we get 1 over x. Okay, let's see, can we do any simple? I'm not going to worry too much about simplifying here. 2u squared plus v squared times 2u plus 1 over y times 2u cubed plus v cubed times 3u squared. Okay, I'm going to take that as my final answer. Now, obviously, there are some things that we could do to simplify this if we wanted to. Okay, we could multiply some things together. We could substitute in x and y according to what we have up here and get our answers in terms of u and v. I'm not a huge fan of doing that because the point really here is more about finding a formula for the derivative and less about simplifying it. Okay, So what about the derivative of z with respect to v then? That's the other thing that we wanted. Okay, so going back to our diagram, okay, I'm going to use red to highlight the paths this time. We want to find all the paths that go from z to v. There are a couple of v's sitting down here. So the first path is going to take us from z to x and then from x to v. If we put that together in terms of derivatives, it's going to be partial z partial x partial v. Okay, and then the next path down to v is going to go partial z partial y partial v. Okay, and again, it's about taking derivatives, and notice that we already calculated a couple of these derivatives above, partial z partial x and partial z partial y. So instead of doing those all over again, I'm just going to use the fact that we took those two derivatives and we got 1 over x and 1 over y. Okay, so before we do anything else, I'm going to fill those in. And then the pieces that are still left to calculate are these. Okay, so partial x partial v, let's see, going up to our function for x, take that derivative and we're going to get 2 u squared plus v squared to the first, and the derivative of the inside with respect to v is 2v plus, okay, and then we've got the 1 over y, which is what went with partial z partial y, and we've still got to do this derivative, partial y partial v. Okay, so looking up at our function y, that derivative is going to be 2 u cubed plus v cubed times the derivative of the inside with respect to v will just be 3v squared. Okay, and without worrying about simplifying then, that should be our answer to that part of the problem.